Howdy. Hey, how would you like to do a little more work on this 7-2 trig substitution stuff? Today we are going to take a little bit deeper look on these trig substitutions, and our technique is going to involve completing the square. I think we only have a couple examples to work through. So when I look at this, it's not quite the style of what we had before, like 1 minus sine squared theta equals, would that be cosine squared theta, right? It's not quite that. So what we need to do, and u sub wouldn't work because I can't let u equal that. It wouldn't come out just as an x squared. So what I think we should do is complete the square. And as you recall, that is something that you learned in Algebra 2, I believe. So I'm going to organize these terms that are sitting under the radical. And then there's going to be, something that we're going to add to this and so forth. So, but before I start to do this, I'm going to factor out that negative so that I'm leading with a positive x squared. Now, what would it take to complete the square here? Well, you take your middle term and you divide it by 2, and then you square it. So I'd have -1, and now I'm going to square that. So it looks like if I put in 1, I will have a nice completing the square. But I can't just invent and create numbers in my equation. That'll throw things off. So I have to do an opposing, either subtraction or addition of that same number to offset my invention there. So really what I invented was a -1. So I'm going to offset by adding a +1 to my completion of the square. Where does that take us? Well, I'd have negative x minus 1 quantity squared plus 1. This stuff, reduces into this perfect square. Now, over to the left, and let's work through this problem. So I've got x squared over square root 1 minus x minus 1 quantity squared, because I knew that I would probably prefer to have this in this form so that it looks like 1 minus sine theta squared, which would turn out to be cosine squared, right? That was my motivation for the reorganization of the order, dx on that. Now we go into our trig sub. So I think what I'd like to do is just erase my completing the square, because you should have that down just to give some more workspace. Now we're back to what we were doing previously, where we just set this up. So I'm going to let x minus 1 quantity squared equal my sine squared theta. Take the square root of both sides. Take the derivative of both sides. Now, where do we go from there? The x squared part's kind of bugging me on the top. All right. On the bottom, I'm going to have 1 minus sine squared theta. dx becomes a cosine theta d theta. And then we've got this x squared going on. What's the deal with that? Well, I'm going to need to take this and move, maybe I should go 1 plus. 1 plus sine theta, right? Add 1 to both sides, and I get 1 plus sine. So that's going to be this stuff squared. X squared would then be 1 plus sine theta squared. Ooh, this is getting complicated. So I have 1 plus sine theta quantity squared. All right, now on the bottom, we can simplify. This would become a cosine squared. And then we then take the square root. So on top, I have 1 plus sine theta squared cosine theta d theta. And on the bottom, we have just square root of cosine squared, which gives us cosine theta. Ooh, looky there. We get our cosine thetas to eliminate, And is that good or bad? That's not, I wish I would keep cosine there because then I could have used u sub. Now let's expand because that's the only choice I think we really have. Requires a parenthesis there. Let's expand that 1 plus sine theta quantity squared. That expands into a 1 plus 2 sine theta. I have no problem integrating that. I have no problem integrating that. This is my problem child. So that we know how to deal with. Let's integrate these first two things and get them done with. One would integrate to theta because we're with respect to theta. 2 sine would integrate into a negative 2 cosine theta. And then we're left with this integral of sine squared. But we know how to deal with that. That becomes a 1/2 1 minus cosine 2 theta d theta. Correct? Now, oh, no problem. We can integrate this ending stuff, can't we? So we've got theta minus 2 cosine theta plus 1/2. Set up a parenthesis for this new stuff that we're integrating here. So 1 with respect to theta is going to be a theta minus cosine integrated would be sine 2 theta. But because of the 2, that would be that little u sub, wouldn't it? That would be a du equals a 2d theta, but we need a 1/2 du equals a d theta. Many of you probably said, just put the half down. You're right, because that's what it requires. All right, I think we got it. Now, is there much that we can push together? I've got a theta plus a half theta. Remember, this is going to go through. So that would give me a 3/2 theta minus 2 cosine theta minus a 1/4 sine 2 theta plus c. Holy cow. All right, now we're in thetas, but we need to be back into x's. That's probably going to be a triangle work based off of x minus 1 equaling sine. I'll rewrite that down here. X minus 1 equals sine theta. Triangle that baby. Put my theta down there. Sine is opposite over hypotenuse. So my 1, my x minus 1, this would be 1 minus 1 squared minus x minus 1 quantity squared square rooted. Which isn't, well, it is very similar to what we started with, isn't it? And this is equivalent to that. So if we wanted to, we could simplify this out. Do you want me to do that? Let's see how that, whoops, didn't really, let's make it into a radical. 1 minus x squared minus 2x plus 1, and then send your negative through. Just trying to show you how this comes back to the original quantity. Negative, positive, negative 1. All right, the 1s are out of there. So this really truly is a negative x squared plus 2x, which I believe is what was in our original, yes, right there, in our original problem. All right, so I'm going to erase all this because we proved out that this is equivalent to a square root of 2x minus x squared. You know you're doing your problem right when this piece that you had to find matches what you originally started with. It's a good feeling, isn't it? All right, so now we've got to solve for theta. Oh, x minus 1 equals sine theta. How do I solve for theta? I sine inverse both sides. If I sine inverse a sine of theta, these negate each other, and I get theta equals. So this becomes a theta equals sine inverse. So a 3/2 sine inverse of x minus 1 minus 2 cosine of theta. Cosine is adjacent over hypotenuse, so that's going to be a square root 2x minus x squared minus a 1/4 Oh, son of a gun. Um, we get 2 theta. That is equivalent to a 2 sine theta cosine theta. Little trig identity there. Now, trade out sine and cosine. We're almost done. 3/2 sine inverse. This is one incredibly long answer. A fourth times a 2 makes a half. Sine theta was an x minus 1. Cosine theta was the square root business, 2x minus x squared, right? Adjacent over hypotenuse, and plus c. There is our answer. Holy camole. But it's really similar technique as what we've learned the last 2 days. The only additional thing we had to do was complete the square to get it in the form that we were familiar with from the 2 previous days. Now, another one where substitution wouldn't work. It's not a trig inverse, off the bat. So complete the square. T squared minus 6t plus something plus 13 minus that something, right? Fill in the box. 6 divided by 2, I guess it's negative 6, quantity squared equals a 3 squared. A negative 3 squared. So negative, fit it in there somewhere. Looks like it's 9 to me. I add 9, I subtract 9. That'll give me a t minus 3 quantity squared. There's that perfect square we created. Plus 13 minus 9 is a 4. That is what we want to turn our integral into. It's an equivalent statement to t squared minus 6t plus 13. These two statements are equivalent. dt over square root t minus 3 squared plus a 4. Seriously. Okay. And I am at a loss right now. I'm trying to find my mouse. Okay, I think I figured it out. I took a moment here to think about it. I think we're going to make use of this identity because I see an a squared plus a u squared idea. We probably actually could, but then we got this square root going on. So we'll figure this out. If I want a 1 to be in there, then I probably want to factor a 4 forward. So I'm going to have a dt square root, factoring a 4 out, we'll make this, let's make a big parenthesis, t minus 3 quantity squared over 4 plus a 1. Okay, and then that means I could take out a 1/2, couldn't I? dt, and then we're sitting with 1 plus t minus 3 squared over 4. Let's let a u equal, not a u, let's let tan squared theta equal a t minus 3 quantity squared over 4. Beautiful. That means that tan theta is equal to 1/2 t minus 3 squared. The derivative would be secant tan, wouldn't it? Secant theta tan theta equals 2 comes down, and we just get a t minus 3 d theta. Dt, I'm sorry. Dt, yeah. And this would be d, and then multiply, this would be dt d theta. And so this would be a d theta. Okay, multiply up by d theta. I had to keep track of what was my independent variable, and I wanted theta to be my independent. Okay, now back over. Let's do our substitutions. We get a 1/2 dt. Oh, damn. That doesn't quite work, does it? So I don't have a t minus 3 up on top. Son of a gun. Secant, this is just getting messier. Okay, I keep working my way through. I did notice that I think I had kept a squaring on this. That should be removed because we took the square root of both sides. Then that's going to keep a 1/2 here, t minus 3. If I substitute t minus 1/2 t minus 3 is equivalent to a tan theta, then I can get a dt equals a secant theta tan theta divided by tan theta d theta. Tan thetas are gone. Okay, so dt exchanges for a secant theta d theta, and on the bottom we get a 1 plus tangent squared. So far, I think we're okay. Then that's a 1/2 integral secant theta over, this is a secant squared, isn't it? But we're taking the square root, so that'll create a secant theta in the bottom. I like it, d theta. Now, those get removed, and we have a 1/2 integral d theta. That integrates into a 1/2 theta plus c. And then we need to solve for theta, don't we? So theta, from this we get a tan inverse on each side. So I get a tan inverse of 1/2 t minus 3. And that seems like there's our answer. 1/2 theta is a tan inverse of t minus 3 over 2 plus c. That was crazy. I didn't have my notes to go by, so I was kind of having to think forward a little bit and see where this was going. But I mean, it's kind of fun, and it looks good. So there you go. Completing the square can get kind of crazy. You have 3 to do tonight that involve completing the square. I did provide the answers, and I did a couple different versions because depending on what route you go, you might get a little different. Wonderful. We got through it.